Now we're going to look at a few questions with the angle properties of quadrilaterals. So once again, we're going to look at determining the sum and measure of the angles in a polygon, in particular in quadrilaterals, and understanding the types of angles in quadrilaterals. So my first question is, what is the sum of the interior angles of a quadrilateral? If it helps you to think about this, think of a square. A square or a rectangle are both quadrilaterals. They're the most common ones we might see. So they're the easiest ones to think of. So if I know what each angle in a square is, I should be able to add them up to determine the sum of all the angles in a quadrilateral. So the answer to this is going to be, if you think again of a square, each angle is 90 degrees, and we have 4 of them. So it's going to add up to 360 degrees. That is true for all quadrilaterals, by the way. It's not just squares or rectangles, but any type of quadrilateral. They're all going to add up to 360 degrees. So my next question is to classify each quadrilateral and identify any equal angles. So I'm going to label them as A, B, C, and D. So for A, we have a quadrilateral where we have a right angle here and a right angle here, and we have this side is equal to this side is equal to this side. So when opposite sides are equal and we have right angles, we have rectangle. I'm going to skip B for the time being and go right to C, because C, we have right angles again, right here and here. And we know this time that all 4 of our sides are equal. So when we have something with all 4 sides equal and right angles, then that's going to be a square. So get the easy ones out of the way. In B, we have these arrows that we see here and here represent parallel lines, whereas these single lines represent equal length sides. So when we have a quadrilateral with one set of parallel sides and one set of equal sides that are not the parallel sides, we call that an isosceles trapezoid. And lastly, in D, we have one set of arrows here, which means those sides are parallel. We have another set of arrows here, which represents those sides being parallel. So that means that when we have 2 sets of parallel sides in a quadrilateral, we're going to have a parallelogram. Okay, so now we have to look at determining the equal sides. So I'm going to erase some of this. So we can look at our sides. Okay, there we go. That's all erased. So what are the equal angles in the rectangle? I'm going to label them in the rectangle with dots. So I know these are both 90 degrees for sure. So they're equal. But the other 2 angles is a rectangle. So the other 2 angles are also going to be equal. So all 4 angles in the rectangle are going to be equal. Well, a square, we're going to see the same thing. I'm going to label the 90 degree angles in the square with dots as well. So all 4 angles, once again, are going to be equal. Now I'm going to look at my trapezoid. It's an isosceles trapezoid, which means one set of sides is equal in length. When we have an isosceles trapezoid, what we're going to find is that we're also going to have, I'm going to label one set of angles here that are equal by x's. This angle here and this angle here are going to be equal because it's an isosceles trapezoid. And actually the other two angles, which I'm going to label as O's, they're also going to be equal. So the two angles at the base and the two angles in, I guess, the ceiling of our trapezoid, they're going to be equal to each other. In my parallelogram, I have two sets of equal angles as well. I'm going to label one with x's. So this angle right here is going to be equal to the opposite angle. So I'm going to label them with x's, and the other ones I'm going to label with O's. These are also equal angles. In any parallelogram, opposite angles are going to be equal. In a rectangle or a square, all angles are equal. They're all 90 degrees. In a trapezoid, an isosceles trapezoid, your base angles, which I've labeled x's, and the top angles, I guess your ceiling angles, are going to be also equal. So I labeled them as O's. So to summarize, for any quadrilateral, when we were looking at the example, I asked you to think of a rectangle or a square, but this is true for any quadrilateral. The sum of the angles is going to be 360 degrees. The reason is that any quadrilateral can be made by combining two triangles. If we put two triangles together, then we're going to make a quadrilateral, as long as their shared side is exactly the same length, of course. That's very important there. A square has all right angles and all sides equal. A rectangle has all right angles and opposite sides are equal. An isosceles trapezoid has one set of parallel sides and the other pair of sides, the other non-parallel sides, are equal in length. And a parallelogram has opposite sides parallel to each other and opposite angles equal. And as a result of that as well, I haven't mentioned it yet, when opposite sides are parallel in a parallelogram, that means that the opposite sides are also equal in length to each other.